log out, or you close the application, right? Next time what happens is, when you access the application, you can see those items, right? So what happened in the background? The state was stored. So, and if you did some shopping there, you can go back and see the order history also. So similar is the case with the banking side or the chat applications or the gaming applications. What happens is they store the state in whichever state the user left the performance or the interaction that it performed with the application. So this is some sort of a metadata that is being stored. So to store all these type of data, stateful applications require storage. Now, which type of storage will you prefer? So there are multiple type of storage. These are so if you go ahead and search on Google, you'll find a different types of storage. But broadly, these are the two ones which I feel fit and are the most appropriate. The one is persistent storage. So persistent storage is designed to retain data beyond the life cycle of pod. This type of storage is essential for stateful applications that must maintain data integrity across restart and rescheduling. So like I just explained, that if you have some data like the items in the cart, even if you don't even if you're not using the app, when the next time when you go, you should see those items in your cart. So persistent storage is used for services like user accounts and order processing, where data durability and reliability are crucial. The next is ephemeral storage. So the containers were usually in earlier days were ephemeral. So this is like a temporary storage that is portable but not durable, since it is destroyed along with the life cycle of the pod. So it is ideal for workloads that do not require data persistence beyond pod's life cycle. So for example, if you have to cache data in persistent storage, or uh, uh, where the data is temporary and the performance is critical, so you don't want to store the data beyond the pod's life cycle, therein you can use these type of storage. So for persistent storage, let us understand some of the Kubernetes concepts. So the first thing is, if you want to have a persistent storage, uh, is storage class. So storage class in Kubernetes provide a way to define different types of storage that are available in the cluster. So suppose you have some external storage, or you have some path that you want to mount. So storage class allows you to allows for automated and flexible provisioning of storage resources based on the application requirement. But in that scenario, you to make that storage available, you will have to request for that storage. So that's where the persistent volume claims scenario comes. So PVCs are the request for storage. Now what they do, they abstract the detail of the underlying storage resource and allow the users or the application the DevOps engineers to request specific storage capacity, access modes, and other things without knowing the underlying storage infrastructure. So they don't have to worry about where is the storage, what is the configuration. They just have to provide a specific detail, and they can claim that storage. But how to make sure that the storage maintain the persistent data? See, you have a storage. You can claim that storage using PVCs, but then how will you maintain ensure that the data is persistent? And when the pod dies, or a new pod comes up, the same storage is connected to the new pod. So how will you ensure that? And that's where the concept of PVs come. So PVs represent a piece of storage in the cluster that has been provisioned by an administrator, or dynamically provisioned. We'll understand the concept of provisioning in the coming slides. So PVs persist beyond the life cycle of any pod that uses them. So Kubernetes provides two ways of provisioning the PVs. One is static provisioning, and the other is dynamic provisioning. Static provisioning. So here, static provisioning refers to manually creating persistent volumes beforehand. So what happens is, if you are aware of like how much storage you want, how you are going to claim it, and all other requirements that are there, then you can actually go ahead with the static provisioning, wherein you create the PVs yourself, which can then be claimed by the PVCs. So admins can create the PVs and specify the underlying storage resources underlying storage resources, and these PVs are then available to be claimed by the PVCs created by the application or by the user. So these PVs are pre-bound to specific storage resources, which can then claimed by the PVCs. Now, the concept of binding we'll understand after we understand the provisioning first. So, what are the benefits? Let's look at that. So, it provides a complete control over the exact storage resource being used. So, like I said, you are in control of how much storage you want. It is ideal for scenarios where the exact storage requirement are known before the application deployment. So yeah, you have an understanding that I'm going to need 1 GB of storage in the whole process, or when the application is deployed. Then in that scenarios you can pre-allocate the storage based on the expected usage pattern. The next is dynamic provisioning. So unlike static provisioning, dynamic provisioning automatically creates a PV when the application requests a PVC. So when the PVC is requested by an application, it wants a storage, then uh, uh, with dynamic provisioning, a PV will be created. This approach provides a seamless way to allocate storage without needing to pre-provision volume. So you don't need to provision beforehand. When you are creating the application, your stateful applications, at that time only the PVCs will create a PV. So so there is one thing to this. Like if PVs are available of the requirement which PVCs want, then those PVs can be claimed. But if PVs are not available with the requirements that PVCs are mentioning, then in that case the PVs will be dynamically created. So, what are the benefits of this? So, it simplifies the storage management by automatically handling PV creation. So, it's actually a very easy process, because what happens is you don't have to worry about how much on the fly storage will be needed. So, this reduces the need for manual intervention also, and the chances of human error. So, now that we understand how PVs are provisioned, we can understand the concept of binding, which I was talking about, that PVCs can create the PVs. So binding PVs to PVCs ensures your application receives the storage it needs. When a PVC is created, Kubernetes matches it with an appropriate PV to fulfill the request. This process connects the abstract storage request PVC and the concrete storage request PV. So what I mean to say in this is, when a PVC is created, when you are trying to claim a particular storage, in that scenario, Kubernetes finds a matching PV. Okay, if it is able to find a matching PV of the requirements mentioned in the claim template, it will use that. If not, then it will create dynamically. If dynamic provisioning is enabled, it will create a PV. The PV is then marked as bound to the PVC, and the storage becomes available for use by the application. So we will see a demo actually, wherein we can see how the PVCs are bound to the PVC. So before we deep dive into the application requirements and see a demo, let us understand some of the needs of a stateful application. So a very generic need of of a stateful application is it requires ordered deployment and scaling. So like you don't want, suppose you have a stateful application of suppose some databases, and you have a master slave setup. You don't want your slaves to come up before the master. You want the master to be provisioned first, and then then provision the your slave servers. So in that case, with proper configurations, you can actually have ordered deployment. Similarly, if you want on the fly, if your usage increases, you can scale the applications. Okay, you want that feature. Then you want a stable network identity, so that if a pod dies, a new pod comes up, there are no connectivity issues. So the identity of the pod is still maintained. And then you'd want an ordered and graceful termination of your of the resources that are there in your cluster. So so if you want all these are a very basic type of requirements of a stateful application. Now in terms of storage, suppose you have defined a fast SSD storage class that has high performance SSD storage. Now in that storage class, you have already mentioned how much storage is available. Now an application comes and it requests 5 GBs of storage. via a PVC. In that scenario, using the storage class, you can actually you can provide 5 GB of storage using PVC. But then to claim that storage, what will happen is a PV will be created using the storage class, which is binded by the PVC. So to manage a stateful application, what you need over here is some sort of help or some sort of API object which can actually help you to manage those stateful application and help you with those features like order deployment and scaling or stable network identity. So here comes the concept of the stateful set. The stateful set are Kubernetes API object that ensures that each pod has a persistent identity, and it assigns a unique identifier such as persistent host name and volume to each pod, which persists even if it is recreated. So, with the help of stateful set, you can actually deploy a stateful application, manage that stateful application, and ensure that it has an ordered deployment. You can scale it based upon a requirement. It has a stable network identity, and depending upon what type of PVCs you have created or PVs you have created, your data is persistent. So, with the help of stateful set, that is achievable in Kubernetes. So let us go ahead and see a demo of static provisioning. So we have understood here the concept of static provisioning, right? Wherein we are manually creating the PVs using the stateful set. We are going to create the PVs. Sorry. Let me go ahead and share my terminal. Malu, could you confirm if the terminal is visible? Can anyone confirm if the terminal is visible? Thank you, Ram. Okay.
Yeah, it's visible.
Yeah, thank you. So, okay, I think Ram added a comment. When I say PVs, it's persistent volumes. When I say PVCs, it's persistent volume claim. I think with the example, will be much more clear. And I'm sorry if I have used them together like a slang. So, let us go to first static provisioning. So, like I said, in case of static provisioning, we are going to first create the PVs manually. So, let us quickly first see the configuration of PVs. So here I am saying I am creating a persistent volume of the kind persistent volume. I have set a name of it as static PV, and I am providing it with 10 GB of storage. The access mode is read write once. And here I have mentioned the persistent volume reclaim policy as retain. So this, let's pause for a second and understand this. So uh, there are two types of reclaim policies that are supported. Okay, the one is retain, the other is delete. The retain means when your PVC gets deleted, your PV will still remain. So that means your PV will not die unless and until you don't go and kill it. In case of delete, if the PVCs get deleted, the PVs will also get deleted. So PVCs, on the deletion of PVCs, the PVs will also get deleted. So we'll see that with the help of example also. And in this case, I have not created a storage class. Why? Because I have used a host path and used a mount path to data the local path that was available, and I'm not using any external storage specifically. So let me get the status of my cluster. Okay, so it's up and running and it's good. So we'll go and apply the configuration for PV. So let's do kubectl get pv. Oops. I think I have PVCs. Okay, let me just go ahead and so if you can see, there are static PVs that is being created. I wanted to delete some of this on my storage which was there. So just yeah, I should delete. Just give me a second and I'll clean this so that it is properly visible to you guys what I'm trying to say. Yeah. So we just applied the configuration for the static PV, static provisioning. So I have named it as static PV. So the PV is successfully created. If I just go ahead and do kubectl get PVC, so there are no resources on my namespace. So you can see it's deleted. So now, since we have created a PV, let us go ahead and create a PVC. So now PV is already available on my cluster. So when I'll go and ask for when I'll go and create a PVC, it will look for a PV of the requirement that are mentioned in the PVC, and it should be able to claim the static PV. So we look at the configuration of the PVC. We have set the kind as persistent volume claim. The name of the PVC is static PVC. The mode is read write once. Storage 10 GB we are requesting, and storage class name is set to manual. So that it will use the storage class as the same that was mentioned in the PVC. Yeah, this one. Okay. So let us go ahead and apply the PVC. So PVC has been successfully created. And if you look at the status of it is static PVC is the PVC we have created, and it is directly now bound to the volume static PV, the PV that we just created before this, and the capacity is 10G. The storage class it is using as manual, and it has read write once access. So the PV and the PVCs are up. And if you see the reclaim policy, retain. So once we are done with the demo, we'll try deleting and see whether it goes or not. So if we see the earlier, we saw the earlier status of the static PV. It didn't show the claim. Now it is showing that it has been claimed by the static PVC, which we just created 3 minutes 40 seconds ago. So now I was talking about the stateful applications. So stateful applications require the persistent storage. So now we have a volume available that can be claimed. So the thing is, we in this demo we are going to create a stateful application using Nginx, and we could use an advanced example also like database or something. But I have kept it simple and used simple Nginx, and created the configuration of a stateful set, which will help us create and manage a stateful application. So here, if you see, I have set the kind as stateful set, the API object, then the name as the static stateful set. In the default namespace, we are going to create the stateful set, and this will have the application will have 3 replicas. What does this mean? Basically they are they once this is applied, you are going to see 3 pods being created. That is what the expectation is. So if we get pods, there are currently no pods running on our cluster. Then we have set the label as static app. Then we are going to spin up a container, and we are using the image as nginx latest. We have set the port as 80, name is web, and we are providing a name as static storage for the volume mount, and setting the claim name as static PVC, which is the name of our static PVC. So in this case, we are ourselves providing all the details. So let us go ahead and apply the configuration. So it has been created. Uh, Let us do. So it's ready. You see, the stateful set has been deployed successfully. Now, if we go and so we just saw the pods that were not, no pods were there on our cluster. Now, if we go and do, we can see static stateful set 0. I mean, so the nomenclature is it appends, uh, it does an indexing, which is easy to follow through, and you can see an order deployment over. So all these 3 pods we can see are up and running. And if we go ahead and describe one of the pods, we are going to see the storage that it is using. See, so the static storage, and the PVC for that is static PVC. And this static PVC is bound to static PV, which is using the storage class manual. So we can validate from the pod. So the stateful application that we just created, that the PVC that it has claimed is static PVC. Now to see whether, so we have our stateful application up and running, which is using a persistent volume. Now the thing is, the reclaim policy that we had set for the static PV was retail, if I'm correct. Yes. So this means that if the PVC is deleted, our PV should not get deleted. So let us go ahead and delete our. First, we'll have to delete. So we don't want to leave the resources up and running over here. And plus, the stateful set pods are using the PVC. So we cannot delete without deleting the stateful set. So it's a good practice. You first delete the stateful set. So it has 3 replicas that we talked about, 3 replicas up and running. We are going to delete it. So this has been deleted. Okay. Now if we go ahead and do PVCs, you can see our PVCs and PVs are still there. Okay. But the pods would have been gone. Yep, the pods are gone. So let us go ahead and now delete the PVC. If you see the status of the PV over here, you can see it shows it has been claimed by the static PVC. Now if we go and do PV, Okay, just give it a second. It is released. If you can see, it is updated. So earlier, if you see the kubectl get PV, you could see the status was bound and it was claimed by static PVC, right? Now, if you see, the status has been updated as released. So it's not anymore being claimed by the PVC is deleted, and now it is not, since it is released, it is not anymore claimed by the static PVC. So the status has been updated as released. Since the policy is retained, if you want, you can go ahead and directly delete it. So what we'll do, we don't want. So the next what I want you to show to you guys is dynamic provisioning, wherein if we create a stateful application using the stateful set, then in that scenario, the PVCs would automatically be created, the PVs would automatically be created. So to do that, I am going to delete the resources. Delete PV. So the good part about this is, if you create a new pod or you deploy the application again, you can connect the same PV to the same PV can be claimed by a new upcoming PVC that you create. So the PV has been deleted. Yes, I will go back to the top to see if anyone has. Okay, type a bit higher. Okay, and type. So the demo of the static provisioning we have seen. Next, we are going to see the demo of dynamic provisioning. So in dynamic provisioning, I mentioned about automatic creation of the PVCs when the application requests the PVC. So let us go ahead and see the configuration of a stateful application being created with the help of stateful set, wherein the application itself will claim a PVC, will request for a PVC, and then the PVC will claim for a. So I have one configuration only. It is that simple. So the benefits that we actually saw, you don't have to go ahead into creating a lot of resources. This is like a lot of automation that you get and least error prone. That's what. So that configuration for dynamic provisioning, we have set stateful set. We have named the stateful set name as dynamic. It will be created in the default namespace. Again, we are creating three replicas. The labels we have set as dynamic app, container with the dynamic name, dynamic container name. And we are again using the same example of spinning up a container with Nginx, running on port 80. And here, if you see, we have set the volume mount name as dynamic storage, for which now we are defining the volume claim template. So if you, okay, it's not there. If you see over here, the volume, uh, we provided volume mount over here, and then we defined uh, volumes only, and with that we defined the PVC that we wanted to use. In case of dynamic provisioning, what you have to do is you have to define the volume claim template. Now what stateful set will do, for each pod, it will create a unique PVC. So, like in the previous example of static provisioning, we created only one PVC, but then in that case, uh,
Sonali,
yep,
if you don't mind me interrupting you, can you just make the terminal a little small so that you're not typing at the very bottom of the screen? Looks like it's hard for a few people to catch that. So,
yeah, yeah,
can you
sure.
just make it a little small so it doesn't get hidden by any of the other things?
Okay.
Sorry to disturb you.
No, 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 not a problem. That's actually a good feedback.
Yeah, I think this should be so much better. Thank you.
Okay. So what I was saying, yeah. So if we see the configuration of dynamic provisioning, uh, we can see over here that we have to define the volume claim template, wherein we can mention the name and the access mode, like we did for the while we were creating the PVCs. We mentioned the access mode. So similarly, you can mention for the template what access mode you want, what is the size of the storage. So I've kept it small actually. What is the size of the storage you want, and if you don't set the policy, it will by default be delete. So let us go ahead and there are no pods, there are no PV, there are no PVC on our cluster right now. Okay, and definitely no stateful. Sorry, my bad. Stateful set. Yep. So let us go ahead and apply that configuration. Okay, so it has been created. Let's go and do. So it's getting ready. You can see 1/3. Let's do pods. So you can see the nomenclature is like indexing is proper. All the pods are coming up, and it's time to see whether the persistent volumes were created or not. So in the configuration, we mentioned about the volume, and I told you guys that three PVC would be created. So the stateful set is actually creating one for each pod. So if you see 0, 1, 2, and if you see the status of, reduce the font a little. Okay. Yeah. So if you see the status of it is bound. So the PVCs are actually bound to a volume, and these are the volume. Now where did these come? Let's check kubectl get PV. So if you see, the PVs have been created dynamically, and these are the IDs or the names, you can say. I think this is creating a name on a random basis. So if you see 50 is, yeah, with 1, 08 is with stateful set 2, F0 is with stateful set 0. So F0 is with stateful set 0. I'll remember this one so that I can use it later. So like I said, since we have not set the reclaim policy, it is by default set to delete. And you can see the status of the PVs. So you can see the persistent volume being created and the status is bound. Now these have been claimed by the PVCs, and these are our PVCs. This one, the first one. Let us see if the stateful set is now 3 by 3. Yep. So you can see all the stateful set with 3 replicas is ready, and the storage has been successfully created. Now let us go ahead and check, describe one of the pods. Okay, so if you see here, the persistent volume claim has been set to this one. Now, as I was saying that since the reclaim policy it has been set to delete with this, uh, let me go ahead and delete first the stateful set, and then since no PVCs would be utilized by the stateful set, we would be free to delete the PVCs. But then since the reclaim policy is set to delete, when we delete PVCs, the PV should also get automatically deleted. That's a deletion part. There is one more part that I think I covered earlier. I missed to show the demo for that. In this scenario, suppose one of the pods dies. Okay, uh, what will happen then? Let us see. So you want a persistent storage, right? And you have storage already created. So this dynamic stateful set 0 is bound to PVC F0, right? And it is running from how much time? Like so it's running for from 4 minutes now. Okay. Now if I go ahead and delete one of the pods, what the stateful set would take care of when the pod gets deleted, it will spin up another pod, but then in that scenario it is not going to delete the PVC. So and the PV. So if you see the stateful set 0 and it is bound to PVC, this idea. I mean the PV is this is the persistent volume name. So when we delete the pod, it should again, the pod that comes back should use this same PV. Um, so you can see a new pod has come up, and if we go and do a PVC, you can see the set 0 and F0 has not been deleted. And if we describe this one, this new upcoming pod, you can see again it is using the same PVC which is connected to the F0 PV. So in this scenario, this whole scenario, what benefit you are getting out of it is for a stateful application, you were able to provide for a persistent storage. So even if the pod dies, you don't have any data on the pod. You are maintaining it on a storage that even if your pod dies, like in case of backend, suppose the example that we took, if you have some items added to your cart and you are maintaining the state somewhere, even if the pod dies in the backend, the user doesn't need to know all these things, right? So when the user logs in or uses the cart again, the user will see that the items are still there in the cart. So this is all happening because that data is maintained on a persistent storage. Now we can see the example. We can see the demo for deleting a PVC and see whether the PV gets deleted or not. So let us do get PVC is there. Button get PV, all are there. Let us go ahead and delete this one. Okay, first we'll delete the stateful set, okay, so that we don't see a slowness because it is being used by the stateful set. So I am deleting this PVC and the PVC has been deleted. Now if we do PVC, we can see the 01 is gone. And if we see the PV, you can see the F0 PV is F01 is gone. It's not 08 and 50 are there. So since the reclaim policy was deleted, if the PVC was deleted, the PV will also get deleted. So that's how you can actually have an optimized storage. You can manage your stateful applications better. So that's it in terms of demo. I'll quickly summarize what we have talked about in this whole discussion with the help of a flowchart. So a user or a developer creates PVC and a request for a storage. Now, if a storage class is defined, if it is not defined, you can go ahead use the static provisioning. If it finds a matching PV, it will bind a PV to the PVC and attach that to a pod. So the application pod that we I showed you guys, the PVC was bound. Now, in case of dynamic provisioning, what was happening was you mentioned what is the configuration you want for the PVCs, and in that case, with the dynamic provisioning, you create new PVs, and then you bind those to the PVCs, and then you attach them to the pod, and then similarly you can see the application using that persistent storage. So there are some best practices. So uh, by seeing these stateful applications on a cloud native environment, there are some recommended best practices also. So like I showed you, you don't have to worry about how much volume you need or how much storage you want to claim. So dynamic volume provisioning helps you take care of all those things. You can automatically provision storage volumes as needed, and that reduces the manual intervention and enables the seamless scalability for you also. Then the next thing is, one of the other best practices is in this the demo that we saw. I was just using one of the paths that was available on the container, on the cluster as a storage. But then for production environment, you can use SSD based solutions, as they offer faster performance, such as higher IOPS. You can get low latency. You can get which are suitable for application that require a rapid uh, data access. Then the next recommended best practices, you implement data encryption. Now, so there is a lot of data flow that is happening in the process. Okay, so implementing data encryption at rest or in transit will help you ensure all the storage volumes are encrypted. You can use Kubernetes secrets to store sensitive informations, and you can use definitely other protocols also to ensure there is a secure transfer of data. Then the next recommended best practice is automated regular backup, wherein you can implement automated and regular backups for your critical data. You can also implement incremental backups, wherein that will reduce the overhead and improve the efficiency of your overall backup process. So these are some of the best practices that are being recommended in a cloud native environment when you have stateful applications. So that's it from my end. If you guys have any questions, feel free to ask. Uh, oh, Ivan, I'm sorry if you missed it. You guys can ask me or post your questions. Uh, if and I'll try. I think these guys will be sharing with you um, the demo or this whole talk. But if you guys want, I can definitely record the whole demo of whatever steps I have shown and share with these guys, and they can put it on the channel also.
So if anyone has any questions, feel free to unmute yourself and ask, or you can even type it in the chat.
I hope I was not very fast in terms.
No, no, you were great.
There are many things we can, uh,
So I think there's a question from Ram.
or
Stateful workloads on Kubernetes versus stateful workloads on Docker. Differences, advantages.
so. That's an interesting question because I have always explored stateful workloads on Kubernetes. I've never went ahead and explored it on Docker. But considering the workloads, the key differences that you can talk about is how the orchestration happens. Okay, so Kubernetes is designed to handle stateful workloads through stateful sets, like we just saw, and it offers some of the built-in features, like the PVCs that we just saw. So in Kubernetes, what you get, some of the benefits that I talked about was an ordered deployment. You get a predictable scaling. So like you can see 0, 1, 2, there's a very sequence that is being followed. But Docker on its own, it's not an orchestration system. Okay. And you can manage stateful workloads through containers using volumes or bind mounts. But it is it is not much it is not very robust as far as I can tell it in terms of my experience. Definitely I need to research now, Ram, or at least explore for my understanding that how much effort it takes. I'm pretty sure Docker is going to take a lot more effort when you have to maintain a persistent storage, or you have to uh, create a configuration, because there is no as such sophisticated mechanism that is available for scaling or for persistent in Docker, as far as I know. But yeah, I definitely need to check. Uh,
There's another question from Rohit. Sonali, is it advisable to have pod disruption budget in place for stateful set, given stateful set have a ordered deployment and termination?
yes, I think it is advisable. Because you get the features like order deployment and termination with the stateful set, right? So you get with pod disruption budgets in stateful set, you will get protection against voluntary disruptions. You will be able to maintain. So even if your node drains, you will be able to maintain availability of your application, and then stateful set will help you ensure ordered, graceful termination and startup of the pod, which is actually critical for a stateful application like database. So mentioning pod disruption budget should be, I think it is advisable practice. It's yeah, true. But you gave me something to research about. I can just spin up a Docker container and see how much effort it takes just for my learning and understanding now. So we can, if anyone else has any other questions, otherwise we can go back all to the Navratri celebration. Thank you guys for taking out time. I think I know that it is a celebration period, and like everyone is involved in the festivities. So I am glad that you guys found time to attend that.
Yeah, yeah, absolutely. I was going to say the same. I'm for all of us, and I'm RSVP'd at a bunch of places, but I'm glad we all found the time to connect. Also, that was a really good talk. Thank you so much for the amazing presentation, and thanks for answering everyone's questions, and thanks for looking so festive. I think it really added color to our to our celebration today. We also have a talk tomorrow. I hope more of you will be able to join us.
Yes, yes, sure.
I shared the link in one of the comments, and I hope you
It's on
guys will
service
register.
mesh, right?
Yes.
Yes, yes, I remember. Yes, it's on that.
Yeah.
It's going to be an
Awesome.
interesting talk. Yes. Okay.
I think so too.
Okay. Thank you, guys. Thank you for connecting.
Yeah. Thank you so much. Bye bye. Have a nice day.
Thank you. Dhanyavad. Bye.
Bye bye.